Assalamualaikum. I am Manish Agarwal. The last three digits of my ID is 488. Now we are present the topic of parity bits generator and checker. Now I am explain introduction of parity bit. What is parity bit? This slide explain why parity bits are important. In digital communication, data can get corrupted due to noise or interference. To detect this error and extra bit called a parity bit. It added to the original and parity bits helps ensure data integrity during transmission or storage. It insulations on the right shows. Transmitter send the original data stream along with the parity. Example like as odd data 00111 and in here the parity bit is the next bit and receiver may receive to change bit stream because of noise. Example receive 001. The receiver check the parity to see whether the data has been altered. And the next slide, what is parity bit? In here, the three topic of extra bit, error checking, and data integration. First of all, extra bit. A parity bit is simply an additional bit added to log of binary data. Error checking. Error checking it means purpose is to detect errors. If even a single bit changes during transmission, the parity check can rebuff it. Data integrity. A parity helps maintain basic data accuracy by serving as a simple error detection mechanism. Thank you, my next team member. Asif Islam explain the next part of kinds of parity. Thank you.
Hello everyone, my name is Asif Islam. My ID is 2411586. Now I will describe the types of parity. There are two types of parity, event parity and mode parity. In event parity, the parity is chosen in such a way that the number of one is even, including the parity bit becomes even. In odd parity, it's the opposite. The parity bit is set to the number of one is become odd. Parity bit are mainly used for error detection and helping system check whether the data has computing during the transmission. Next slide. Now I will describe understanding three-bit parity. Now let's look how parity works with a simple example of three bits A, B, and C. First we start with original data. Then we generate an extra bit. It is called parity bit based on how many ones are present in A, B, and C. Finally, we attach enough parity bit to end the making the output total of number of bits A, B, C, and P. So the parity bit basically help us to maintain either even or odd number of one, depending on the chosen parity method. Now, my next statement will explain the further presentation. Thank you.
Assalamualaikum everyone. My name is Surya. My ID is 2411539. Today my presentation topic logic expression for parity. Logic expression for parity. Here we can see how the parity mix is using XOR bit. XOR output one only when an odd number input are one which makes ideal parity generation. For three bits A, B, and C parity mix simply. For the expression P is equal to A XOR B XOR C, and this is the expression. The circuit on the right shows there clearly A, B, and A, B are XOR first, and then result XOR with C produce the parity mix. Then next slide. Next slide, you can see truth table or three bits even parity. The truth table shows how the even parity is assigned. For every combination of A, B, and C, we chose P so that the total number of P1 is even. If inputs have odd number, one P becomes 1. If already have a even number once, P remains 0. So is low, the number of
Now I am going to talk about the circuit diagram for parity generator. It is a conceptual diagram for generating a 3-bit parity bit using XOR gate. This circuit shows how a 3-bit parity bit is generated using XOR gates. First, XOR takes A and B. The result is then XOR with C. The final output gives us an odd parity bit. For even parity bit, we simply invert the output with a NOT bit. Now I am going to talk about the next slide, the parity checker. The parity checker is the counterpart of the parity generator, designed to verify data integrity upon reception. If XOR all data bits and the parity bit together, if the result is 0, no error is found. If it's 1, a single bit error has occurred. But remember, parity can only detect a single bit errors. That's all from me. Now I would like to invite my next team member.
Assalamualaikum, this is Muhammad Rakib Hasan and I is 411847. Today I will discuss about application of parity bits. Here we will try to show 5 applications of parity bits. The data transmission, network communication, serial communication, memory systems and digital circuits. The data transmission. When data is sent from one device to another, parity bits can ensure the data arrives correctly without corruption. And next, the network communication. Many network protocols use parity bits to detect corrupted packets. And serial communication, parity is used in serial ports to check if each byte has been received correctly. And the memory systems. In RAM modules, parity bits helps detect single bit errors that may occur during storage. And the digital circuits, many digital systems use parity internally to validate data and ensure reliability. And next, here are the advantages and limitations of parity bits. Here the 3 advantages: simplicity, low cost, and quick detection. They are very easy to understand and implement the parity bit, and only a few gates are needed. And the low cost. Because the hardware requirement is small, it becomes an inexpensive solution. And quick detection, parity can detect a single bit error immediately, giving fast feedback. The limitations. There are some limitations of parity bit: the single bit errors only, no connections, and vulnerability. The single bit errors only. Parity can only catch errors if one bit changes. If 2 bits flip, parity cannot detect it. And no correction. Parity can only tell that an error happened, but it cannot find which bit is wrong or fix the error. And the vulnerability. Multiple bit errors can go undetected and which can cause corrupted data. And in conclusion, we can say parity bits are simple, low cost, and effective for detecting basic errors, especially single bit errors. Although they cannot collect data and cannot detect multiple errors, they still remain an important part of many digital communication and memory systems. Thank you everyone. That was all.